Hey everyone, this is question 11 from Larson Edwards Calculus textbook section 2.6 on related rates. I think a lot of the time AP Calculus students in high school or even maybe some early college students in calculus are scared of related rates problems because there's a lot of stuff going on, there are word problems, and sometimes you even have to know pieces of information from memory to bring into the question to be able to solve it. But I'm here to show you that really you do the same thing every time and they're not that scary. So let's take this one. The radius r of a circle is increasing at a rate of 4 centimeters per minute. Find the rates of change of the area when r is equal to 37 centimeters. So one quick note on related rates. Remember that a rate is a relationship of one thing changing with respect to something else. For instance, your car has miles per hour. So it's how many miles you're going per a given hour. As hours go by, you've gone a certain amount of miles. Miles have increased and time has increased or time has elapsed. So miles per hour is a rate. Oh, sorry. I meant to say miles per hour. Okay. So here, with related rates problems, just gonna copy this real quick. Then we gotta get our perfectly drawn circle here. Step one is to write down key information you are given. In this question, it tells us that the radius r of the circle is increasing at the rate of 4 centimeters per minute. Now remember, this is just like when we said miles per hour as a rate. 4 centimeters per minute is equal to the rate, which is equal to the rate of increase of the radius. The radius of the circle is increasing at the rate of 4 centimeters per minute. So the change dr for d radius over, well, time. 4 centimeters. The length is changing. Change in length. Which is dr. over change in time as minutes go by. So dt. So we have that dr dt is equal to 4 centimeters per minute. This is what we know. But we want to find out the rates of change of the area when r is equal to 37 centimeters. We will write that as the rate of change of area dA dt when r is equal to 37 centimeters. Okay. Step 2 for any related rates problem is to determine the equation that relates the variable we know information about to the variable we want to solve for rate of change for. So in this question, we know about radius r. dr dt is equal to 4 centimeters per minute. We want to solve for a rate involving area A dA dt is equal to what? So, what's an equation relating variables A for area and radius r of a circle? Well, that's the equation for the area of a circle. And this is where, like we said with related rates problems, sometimes you have to know things that they don't tell you in the problem from memory. But I think most of us remember that area A of a circle is equal to pi r squared. So now we've found the equation relating the variable r to the variable we want to know about, which is A. So now step 3 is to differentiate the equation relating the variables. So dA dt, taking derivatives on both sides, is equal to d dt of pi r squared, which is equal to 2 pi r, and the derivative of r squared is, well, I'm sorry, the derivative of r squared is 2r, but it's 2r dr dt. Now is the final step. Apply the specific conditions given in the question to find the answer. What do I mean by that? Well, here it was given that, remember that dr dt is equal to 4 centimeters per minute. And we want to know dA dt if r is equal to 37 centimeters. So from that equation we solve for dA dt is equal to 2 pi r dr dt. And now we plug in what we have. dA dt is equal to 2 pi r. Let's see how to do this lightly. R is equal to 37 centimeters. And dr dt is 4 centimeters per minute. So our final answer is that the change in rate, well, the rate of change of the area with respect to time, if r is equal to 37 centimeters, is 2 pi times 37 times 4, which is 296 pi. And here we actually multiply the dimensions. It's centimeters times centimeters, which is centimeters squared per minute. And that's our final answer.